Okay, welcome to part 2. Let's go through some examples of how to name cycloalkanes and how to draw cycloalkanes. Let's start with number 1. We have a methyl group and another methyl group. Sorry, let's start from the beginning. This is 1, 2, 3, 4, 5, 6. So we have cyclohexane. It doesn't matter which methyl we start with. We could start with this methyl or the one on the bottom, but we just have to go in this order so that the substituents have the lowest numbers. Remember that there's 2 methyls, so we have to group them together with di. So we have 1, 2, dimethyl cyclohexane. Okay, this is 1, 2, 3, 4, 5. So we have cyclopentane. We have an ethyl group up here, a methyl group down here. Our ethyl comes first alphabetically, so we're going to go with 1 here. Our substituent's going to come sooner if we go this way. So our name is 1 ethyl, 3 methyl cyclopentane. Okay, let's go to the next one. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And here we have 1, 2, 3, 4, 5, 6, 7. So it looks like this is going to be a cycloheptyl group because it has a lower number of carbons than our chain up here. So in order to name this, I'm going to name undecane with 11 carbons. And then if I go this way, if I go from left to right to left, my substituent lands on the lower carbon than if I went from the other way. So it's going to be 3 cycloheptyl undecane. Some of these drawings I did not touch. Going down to the 4th one, our ring has 4, and each of our substituents have 3. So our ring is going to take priority. We have a cyclobutane, and at carbon number 1, it doesn't matter which ones get 2 and 3 and 4 at this point because our substituents are only at carbon 1. We have 1,1-dipropyl cyclobutane. We have a cyclopentane, so we can go ahead and draw that pretty quickly. We get to decide where carbon 1 is. Doesn't matter, you can pick any one of these to be carbon number 1. Doesn't matter, I'm just gonna pick this one. We wanna draw our butyl group, which has 4 carbons, 1, 2, 3, 4. If this is carbon 1, then carbon 3 either has to go here or here, depending on wherever you put it. I'm going to number it this way, but you are more than welcome to number it the other way, and that has an ethyl group on it. That is how we draw 1-butyl-3-ethyl cyclopentane. A lot of different ways that you can draw it. This is just one of the many ways. Here we have a cyclopentane with a 5-membered ring. We have an ethyl group, and we have 2 methyls. So we have a methyl here and a methyl here. Our ethyl comes first alphabetically, so we're gonna number it this way, or that way our number 2 carbon has the next substituent. The ethyl is gonna go first because it comes first alphabetically, so we have 1 ethyl, 2 dimethyl cyclopentane. Here, it looks like a very complicated one, but our ring has 4 carbons. So we have a cyclobutane, and it looks like we have 1, 2, 3, 4, 5, 6 methyl groups. Now, this carbon or this carbon has to be carbon number 1. If this is carbon number 1, then this gets to be 2 and 3. If this is carbon number 1, then this is 2 or 3. This ensures that we have the lowest amount of numbered carbons on our substituent. If we include this, then one of our substituents is going to be on carbon number 4, and we do not want that. So if we do the one in red and not green, whoopsies. If we name it based on our carbons in red, we have 1, 1, 2, 2, 3, 3. Hexamethyl cyclobutane. Lots of numbers here, but each of these has 2 methyl groups. So our name looks pretty much correct. Okay, and then our last one, just drawing it, we have just a normal alkane. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. At carbon number 2, I'm gonna go left to right. At carbon number 2, there is a cyclopropyl group, which means we have a 3-membered ring. At carbon 3, 4, and 5, 3, 4, and 5. I probably should have numbered the carbons to start. We have 3 methyl groups, so that is 2 cyclopropyl, 3, 4, 5 trimethyl heptane. If this is not clicking, that is okay. We're gonna do lots of examples in class. I encourage you to, watch the video again, make sure that you have your notes ready, attempt problems if you can, and I'll see you guys in class to discuss this a little bit more.